the motivation for this, the feeling that everyone is using PDF, but few people know something about the internals or how the file format is organized. And other than communication protocols, file formats are much less known in our community, I feel. Why do I think I can tell something about this? I'm working in a software company that's making a document management system, and I wrote the PDF library for this system. And I will also use this library during the lecture for demonstrations. Please hold any questions to that library for later private discussion, because we don't have time to explain the library itself. Okay. What will be covered is a short overview of the history of the portable document format and the relation to its ancestor, PostScript. Some words about the license and legal issues around it. An introduction to the file's format syntax and the basic semantics. And the description of the display model. How images and vector graphics are incorporated in PDF files, how text and font is managed, something about encryption and compression filters, and an overview of tools and libraries and links how to proceed. Well, the past is PDF 1.0 to 1.4. These version numbers of PDF correspond to the specification of the file format. The corresponding reference implementation, if you wish, Adobe Acrobat is usually the minor number plus 1. So Acrobat 5 corresponds to PDF 1.4, for example. 1.5 is currently, well, 1.6 has been announced and the specification is already available. Acrobat is still not. The specification is available since 2 months, and PDF 1.5 is still the current, considered the current format revision. 1.0 to 1.4 was very highly compatible upwards and downwards. So you can open the 1.4 PDF file with a 1.0 reader. You will still have some features within the file which your reader can't process, but that won't prevent the file from being opened and being displayed at all. The features that aren't available in the older readers will simply not work. So for example, if you have a transparency overlay between different color schemes in a 1.4 file, they will still appear in an older reader, but will be simply opaque and not transparent. 1.5 breaks with this tradition of compatibility because people started to compress PDF files with zip or anything else, or gzip, because there was still room for compression. This is due to the object formats which I will describe later. And so PDF 1.5 was introduced a new scheme for compressing those types of objects which weren't well compressible before. But a pure 1.5 PDF can't be opened by all the readers. Well, that's uncomfortable, especially in the Unix Linux environment for which the Acrobat reader is still the 1.4 version. Although there are readers that can open 1.5 like XPDF. 1.6 does nothing new with the file integrity of the file format, but introduces new object types, annotation types, especially to represent 3D CAD images, for example. Besides the Adobe file formats, there are 2 efforts on the way for broader standardization. This is PDFX, different PDFX versions. I can't go into that now due to lack of time. These are ISO standards, so this is not any longer a proprietary Adobe format, but it's an ISO standard. The standard itself is very thin, a few pages, although the PDF reference from Adobe is 1,200 pages, the current one, because the ISO standards only define which features that are optional in the Adobe specification are mandatory in the ISO standard, and which features are prohibited in the ISO standard. The idea is to ensure a certain feature subset which has more stability than the ongoing efforts to develop the PDF format. Even further goes PDF-A. This is still incomplete work on ISO 19005, still a draft. They tend to create a downscript PDF format which should be possible to rely up to 30 years on the stability of the format. We will see how far this will go. I will skip over many information in the following nearly an hour, which is easily available on the web, although I give pointers where to find it, but I will give you an overview which is more difficult to find on the web. The relation to PostScript. PostScript, also in a file format from Adobe, was or is a programming language. It's totally complete. It's Turing complete. It has loops, recursion, conditionals, everything. And you can program every algorithm you want in PostScript. Though it's special domain, so it's designed for displaying images. PDF is not a programming language. PDF shares the imaging model of PostScript, so you can reuse parts of the implementations of PostScript interpreters, and you can omit the complex programming language. PDF is passive data structure, and another difference is in PostScript you have to read from the start to the end. If you want to access any page in between, you have to read everything what is before that. And PDF provides random access to all objects in the file, so you can immediately skip to the page 89, for example, and open it without reading everything else. This is also true through protocols like HTTP. The Adobe Reader will, when opened with an HTTP address, will open that address and skip, just request those bytes which it needs to open the pages you requested. PDF goes beyond PostScript in several features like forms, annotations, JavaScripts that can be embedded, metadata, and many else that's not available in PostScript. And if you, for example, convert a PDF file to PostScript, you will achieve the same print result, but you will miss many features that cannot be represented in any matter in PostScript. So if you use a printer driver which converts to PostScript and then to PDF, you will miss any features which may be any kind of interactive, like hyperlinks, for example. The licenses are similar. Both provide the specification and the format for free use, and don't have any restriction on that. But Adobe prohibits cloning the whole format or parts of it, and simply makes clear that Adobe holds the copyright on the format, but nothing more. You can ask any questions in between if you wish. Okay, the general file structure. looks like this. We have a header, a body, this is the largest part, a cross-reference table, and a trailer. Yes?
Yes, I want to ask how it is about software patents with PDF. Does Adobe hold patents on this format?
No, none that I know of. Although there are some algorithms embedded like RC4 for encryption or the SW format, which had been a patent subject by Unisys. But Adobe holds no patent that are part of that are mentioned in the specification. And Adobe also states in the specification that the general idea to design such a format is in the public domain. Okay, the file syntax. Body, cross-reference table, trailer. Here you have some examples of this. The header is rather small and just contains the comment character and a small note about the PDF version. The version, this is not the only place where the version number can be placed. It can also be here in the trailer, but that's a detail. Followed by some characters, over 128 decimal. The only purpose for these letters is, for example, to make PDF clients aware that this is a binary format and may contain binary characters very much later in the file. So if the FTP client examines the first bytes of the file, it will find those binary characters and switch to binary mode. That's the only purpose. This here is an example of one PDF object. This is a general format how the objects are printed in the file format. An object number, a generation number, the OBJ keyword, and the end OBJ keyword at the end. In between are the object contents, in this case a dictionary. I will describe the object types later. And the next part in the file is a cross-reference table, started by the xref keyword, some information about the following table, and such 20-byte entries, a long list of them. The first one is a byte offset. So this is the object ID of the first object that has an entry here. So this is the reference of the object number 0, which is a fake example. It couldn't be in real file. The generation number of that object and the flag whether this object is valid or not. Followed the cross-reference table is followed by the trailer. Has a keyword trailer, a dictionary with some important links to the inside the where to start within the object hierarchy, the start xref keyword, a byte offset, and the end of file marker. This byte offset points to the start of the cross-reference table. So when you open a file, you start reading at the end. You look for that start xref keyword, read this byte offset, and jump to this byte offset, read the cross-reference table, and afterwards you have a table of all byte offsets of all objects within the file. Then you will find the pointer to the root object in the trailer, and you can immediately skip to that root object and open it and start reading the objects of the first page, for example. PDF features incremental updates, so the header is the only part that is unique within the document. You can append another body, cross-reference, and trailer section, and another, and each one updates the previous one. So if you redefine objects which are already present in the previous version, the newer versions will be the valid ones. So you can exchange whole pages, drop out pages by redefining the contents, adding contents by just appending data to the end of the file. And of course you can remove this at a later time. By using filters, you can write a PDF file complete ASCII, so you 7-bit clean if you want, and PDF provides methods for single pass file generation. So this is obvious in this case. For example, the cross-reference table is known when you have written all the objects. So you just have to remember where you was at when you wrote some object and print the cross-reference table later. Any questions to this? Okay, these are the basic object types. There are Boolean objects, numbers, which can be integers or floating point numbers, signed or unsigned. Exponential notation is not allowed. Then there are strings noted in parentheses, clear text. In a encoding, you can choose encoding for any string, or in hex characters in single angles. Another object type is a name object, something like a symbol identifying as unique identifiers. For example, used in dictionaries as keys. A dictionary is a number of pairs of keys and values noted within double angles. And array, I missed the array. This is noted in, here you see it, and can contain just any number of a list of objects, an ordered list of objects. Then a very important object type is the stream object. The stream consists of a dictionary, which describes the stream that follows, a stream keyword, and an end stream keyword, and everything in between is the data stream. This can be anything, any binary data. Then there is a null object, a placeholder for at some places, and there are indirect objects. So when you can have, for example, an integer here, or a string, or another array, or in such an indirect object. Object number, generation number, and the letter R. So when you encounter this in reading the PDF file, you have to read that object and put it in this place here. For example, if you open a PDF file, you have this trailer I spoke of, and you find the pointer to the root object. This will be an indirect object. Question? The end-of-line character is flexible, so you have such objects as I had here before. You can have any new line character, for example, here and here, and everywhere in between. If you wish, you can format this like you want. And the end-of-line character is very flexible. You can have character return line feed or character return line feed. There are a few exceptions, although for example, the stream keyword must be followed only by character return alone, because otherwise it wouldn't be distinguishable if the line feed would be part of the stream itself or not. These streams can have filter entries that define how the streams are encoded. For example, you can use FLATE compression or DCT compression for JPEG images, and you will define those filters in the dictionary before the stream. PDF 1.5 introduces a new kind of object, or a new kind of object storage called object streams. This will be one stream object, and the stream contains a small table of offsets, and then immediately the contents of other objects. So you can, in the result, you can put, for example, every object besides any other streams in one stream that corresponds to one page, that are needed for displaying one page. And you can compress the stream, of course, and this saves the space. And as a result, you can't expect a clean PDF 1.5 file to gain anything in compressing it furthermore.
Streams
But the stream can, it depends on the filter. The stream can be 8-bit, but you can also have a flat compressed stream piped through another filter like ASCII 85, and then you have a 7-bit clean stream. Okay, this is also how encryption works in PDF. This is simply that all streams and strings go through the cipher. Up to 1.4, you can specify the algorithm, and every string and stream in the file will be encrypted through with the cipher. In PDF 1.5, you have a little more flexibility for distinguishing strings and streams, for example. But that's not that important. There was only one possible algorithm for encryption up to 1.3, that was R34 with 40 bits. I don't need to tell you what this means. Since 1.4, the bit width is increased up to 128, and 1.6 introduces AES as an alternative algorithm. Since 1.4, there was also a possibility to embed unpublished algorithms. This was a restriction or a commitment to US export laws, which are not longer enforcing Adobe to support this, so this is not longer in use. Since PDF 1.3, you can also use public key algorithms. I'm not a specialist in this domain, so please ask me any details. Important thing to mention is that you can specify, you can distinguish between the rights that a user has, what the user may do with a file. Often you will find files where printing is disallowed or copying text out of it is disallowed, but simple display is allowed. This is clearly where you can as you can imagine, for displaying the file, the reader application has to decrypt everything that's inside. So to prohibit printing or copying text is just an implementation of the issue of the reader application.
Excuse me?
Yes?
How's that apply to GhostScript? Because I often use GhostScript to print out or to extract text from PDFs that are print protected or copy protected.
Yes, exactly. The PDF specification has a part in the license that allows use of the specification only if you accept that the reader application has to prevent, has to honor the author's intent. So, of course, you can't do anything about it if GhostScript doesn't do that. Well, you can also patch XPDF if you want, and but that's not what the format is designed for. But, well, that's not the strongest part of PDF. Okay, more to the semantics. Well, perhaps I'll show you a simple example. Okay, I used my library to make a simple PDF file. Looks like this. Nothing special. And now we take a look inside with a text editor. So that's better. So you see the header, the binary characters, and the first object, object number, generation number, keyword, and the end OJ keyword, and this is a dictionary. So this is a dictionary containing the kids keyword, an array as the value of this, and the array contains a reference to another object, object 5. Second key is count, value 1, and so on. Any other types here? No. Well, here's a stream, a very simple stream consisting of only one character or two characters. And this is indeed the smallest possible stream, which requires only a length entry in this dictionary, how many bytes the stream has, and well. So we start at the end reading it. This is the byte offset of the cross-reference of the xref keyword. Starts with, so has 9 entries. And this is, for example, the byte offset of the first object, of the object number 1, which we have here. So the trailer contains, the info object is optional, but the other two are mandatory. So the size entry states how many objects are contained in the file. This has 9. And the root and the pointer to the root object, this is number 2. So we start reading at the object number 2. Is a dictionary of type catalog. Every dictionary of this kind has to have a type entry. Catalog is the type that is the root object. It's only present once in the file, and has a pointer to the pages object. This is the head of the pages tree. I will explain the pages tree later. The page tree is this, having one kid. Page object number 5, this is the page object, defining, well, I will come to the details later. The pages are organized in a tree structure, in a balanced or not balanced. It's up to the application that's creating the PDF. So if you have a PDF file with 1,000 pages, for example, you can have a tree structure. So that in order to find any given page number, you can just traverse a few page objects and you are at the page. This ensures that opening any later page is as quick as opening the first one. Trees are used also for several other structures within the PDF. For example, name trees, outlines, this is a PDF word for bookmarks. Logical structures, for example, you can mark chapters and sections within a PDF file, so a reader application can deal with that and make you navigate more easily within the document, the logical document. Tree nodes can, some sort of the trees can contain data at some nodes in between that is inherited to the child nodes. For example, the pages object, the root pages object could contain data about the physical page dimensions, and unless any page overrides this with another physical page dimension description, this will be valid for all pages below that node. Okay, most basic PDF document, I already explained it with the example. Okay, the content stream. Okay, so this is the root pages object, has a kids member and a number of how many pages are below this node. So this is only one page in this file. Number 5 is the page object. Media block, this is the physical page dimension. This is an array of four numbers specifying the dimension in picas. A resources dictionary defining, for example, the font this is a font name which has to be defined in order to be used in the content stream later. A pointer to the parent object, in this case the root pages object, and a pointer and the contents array. These are the page contents. Also an indirect object, pointer to number 8. This is object number 8, containing a stream, 154 characters, These are operators. Some may look familiar to some of you who are familiar with PostScript. PostScript, for example, contains a similar language. This is just basically a shortened version of this language. For example, in PostScript you have a line to or a move to operator, and this is only an M or an L in PDF to save space. So all these are defining the properties how every object later will appear. For example, this is the font name followed by 12 and the TF operator. The TF operator takes these two parameters and defines the text, the font name and size. This is the BT. The BT here is the begin text operator, followed by a matrix, a transformation matrix. I'll explain that later. The TM operator, which takes all these operands to set the matrix and the string. This matrix defines where the text is, how the angle is, in which direction it flows, and anything else. This is the shortcut for the print command and the end text parameter, and this is all the content stream of the page. Okay, I show you how an update is made. So we have been with the end. Here's the end of the file as we had it before, and now we just append new objects. An update to the info object. This is kind of doubled. This is an update to the page object. The only difference now is that the contents array contains more objects. So the object number 8 is still the one that has been in the file before, but the objects number 9 and 11 are new, coming here in the file, defining a new text, followed by the cross-reference table that contains the byte offset for the object that has been appended, a new trailer, and a new cross-reference start xref offset. This one points to the last cross-reference table in the file, and the trailer of an updated cross-reference has to have a pref entry that points to the byte offset of the previous cross-reference table. So this is a linked list, and you can read every cross-reference table after another until you have everything that's in the file. So these 818 is the same offset as this one. This file looks like this now. Okay. Everything clear, or any questions? Yes?
I have a question. What does the generation number mean? Up to here it's always been 0.
Yes. Object numbers can be reused in a PDF file. If you decide to drop an object and you don't want to reuse it or make it available after an update, for example, you increase the generation number, and then you can reuse the object number. This is just for the object number. It's very rarely used. In most PDF files, you won't find any generation numbers other than 0. Okay. Sorry. Oop. Okay. I already said that the displaying model is identical to that of PostScript, and existing implementation can be reused, and I think so does PostScript, for example. The a PDF extends the display model at some point, for example, for the transparency features, which are not part of the PostScript rendering model, but the basis can be the same. There are three types, common types of content, which are text. You already saw an example, bitmap images, or vector graphics. And for what every content object shares is the idea of a set of coordinate systems that are used to transform between coordinate spaces. For example, you have a standard user space per default starting at the lower left end of the page as in a standard coordinate system, and one unit would be 1 pica, 72nd inch. You can modify that in these coordinate systems, and you need other coordinate systems to transform this content, for example, for screen representation or printing. When you print a PDF file, all the graphics or text that is contained in it will be transformed using coordinate systems, transformations. I'll explain how that works later. To a device space that is specific to a specific printer, for example, or to a screen. There's always a so-called current transformation matrix. If you transform one coordinate system to another, you simply have to multiply the parameters of one system with a transformation matrix. This transformation matrix is a 3 times 3 matrix, and 3 of these values are always constant, and the other 6 define a translation in the coordinate system, a scaling of the whole coordinate system, rotation, and skewing. This picture is from the specification and is indeed the same as in the PostScript reference manual. Is what it unclear or? Okay. The graphic state that is current when you draw some objects is saved. You can save the graphic state on a stack and push it again from the stack. For example, you can define a certain graphic state, put a copy of this on the stack with one operator, make any transformations for some weird object, and later get the previous graphic state from the stack. I, for example, use this for putting new objects on predefined pages. So I put a graphic state save operator on the beginning of the page, which is always the default the default coordinate system. And when I append my own objects on the end of the page, I just get this state from the stack and have a clean default user space where I can navigate within. This graphic state defines not only this transformation matrix, but also all color attributes, overprint properties, clipping the line patterns, how the ends of the lines are shaped and everything else. The color spaces can be anything of RGB, CMYK, gray, ICC-based index, and some others. And colors can have up to 8 bits per component in PDF 1.4 and up to 16 since PDF 1.5. And if you define any object within the file, you can reuse this object as often as you want, simply by placing the indirect object reference in any contents array on any page. The text state is part of the graphic state that defines the character spacing, the distance between words, the horizontal scaling for condensed fonts, for example. The leading, this is the distance between two lines, the font name and size. The rendering mode, this is, for example, an outlined or filled. The rise for superscript, subscript, and knockout. This defines whether overlapping characters wipe each other out or not. You can have type 1 PostScript fonts. You can have true type fonts, and you can have type 0 fonts that are composite ones, and you can have type 3 fonts. Type 3 fonts are useful for any custom characters that you want to create. You can use the PDF or PostScript imaging model to create shapes and define a new font using those shapes. And this will be a type 3 font. You can use different levels of embedding a font. You can, for example, if you use, perhaps the next point first, there are 14 standard PostScript fonts that are required for every PostScript and PDF interpreter to be present. That's Helvetica, Courier, Times, in different styles, bold, italic, symbol, and subdingbat. And if you use those 14 fonts, you're not required to embed or otherwise specify properties of those fonts. You can just use them. Any other fonts you want to use have to be specified in some way. You can specify just the name, then it's up to the operating system or the client application to provide that font with that name. Or you can specify a name and embed the glyph definitions. Or you can embed the complete font program, which defines everything about the kerning and difference between print and screen and everything else. This makes a large difference in how large the representation of the font will be in the file. So,
I sometimes have PDFs with empty text, only graphics shown, but no text at all white. Is there any fallback if the font is not present on the system, or how is that handled?
Yes. When you define a font, you have to define a font dictionary, and this dictionary has to mention which class of font this is. For example, if you specify Arial font, you will find mention that Arial is a Helvetica family font. If the Helvetica family is not mentioned, it's at least stated that this is a sans serif font. So the text will be visible in any way if it's present, and it's black and white, or if it's not white and white, or the reader application has a bug. But normally the text should be present in any way, and if the font can't be found, a default font will apply, either Times or Helvetica normally. Each text can have a different encoding. For example, WinANSI encoding or ISO 880/59. You know that. Okay, an example for bitmaps. I add a bitmap to our demonstration file. Now looking like this. Okay. Last cross-reference table of this. Now, as before, new object definitions. Another time, an extended content array for our page. This is the content stream. The content stream itself does not contain the image, but only references it. It references it by defining the current transformation matrix for that image that defines the place and dimensions of it, and the name, the do parameter. The Q is the graphics stack restore parameter operator. This image here is defined in another object that is referenced in the page object. Here, resources, contains an X object, an external object, an image contained in object number 14. This is this one. So this is a stream object containing the binary data, in this case a JPEG image, specifying the filter, DCT decode, 8 bits per component, the width and height, and the length in bytes of the stream, color space, well, followed by the binary data, and another time the updated cross-reference table. That was it. Okay, I already said the other things.
What format is the binary data?
A JPEG in this case, just copied from the JPEG file, stripped from by the headers. The JPEG markers are cut off, but this is only the rest of the JPEG file directly. You will see details now. The filters you can apply to images. You can apply this to every stream. Indeed, are these mainly. What I just had used is DCT. This is the compression algorithm for JPEG images. Others are, for example, LW, discouraged, or FLATE compression for arbitrary streams. Run length encoding, or CCITT. CCITT in JPEG2 for monochrome images. JPX wavelet formats since PDF 1.5. Well, that's basically it. The ASCII filters are just for stripping the 8-bit of streams. So I have a 7-bit clean file. You can specify alternate representations for images. For example, if you have a very high resolution image containing 20 megabytes of space within the file, and if you don't need that resolution for displaying the file on the screen, just for printing, you can have an alternate representation that is quicker to load and display. Vector graphics, called paths, are generally a sequence of Bezier curves or lines, in a special case, just the same as in PostScript. I don't know if you are familiar with it, but the old Logo language was something similar. You have a starting mark and you go to another coordinate and to another. We define if the space between is filled or not, or with which pattern, and apply a stroke command, and that's it. For example, I'll show you what I will do now. This is the function which will now apply a vector graphics object to our file. I'll just set a color, the line width, some coordinates where the points are, the opacity, that's the transparency level, and then we have for example something like that. Vector graphics are of course freely scalable, and this is the updated section. This is better readable. By the way, this is a PDF syntax highlighting for Vim, if you want. Another time, the content object is extended, where is the content stream. Here is the content stream. This, for example, are the the red, green, and blue values, followed by the corresponding operator, and so on. Just drawing that object. There are some other objects which are mainly annotation types. You know PDF annotations, objects that you can place on PDF files and can move around, also in the reader application. The application types can also now have properties like movies or sound and 3D objects in PDF 1.6, but it's a little bit leaving the original intention of PDF behind, in my opinion. Some other interesting detail, PDF can contain metadata since PDF 1.4 in XML format. That's using the semantics is XMP, Extensible Metadata Platform, developed by Adobe, but widely used now in other applications. XMP is an RDF application, Resource Description Framework. So you can use this to place meta information that you can read with any other application and process without having to interpret all the file and displaying and implementing a display model and everything else. Okay, tools and libraries. The most common library is the Adobe PDF library. This library is sold by a company named Datalogics. You can do everything with this library that you can do with Acrobat, and it's also considered a reference implementation of the file format, but it's very expensive. So there's free room for many other companies making other libraries and applications. A very famous one is PDFlib by Thomas Merz. There are free and commercial variants, and PDFlib is quite good for creation of documents, but has still it's very limited when you want to process a given PDF. You can only copy whole pages out of given PDFs, but not take specific objects or extract images or something like that. iText is a very promising library, especially the Paolo dependent of it. It has PDF 1.5 support. And you can also process existing PDF images with it. For example, place additional objects on given pages. And it's GCJ compatible, so you don't need Sun Java machines, but you can compile command line tools without a JDK using iText. Has also language bindings for many languages. Apache FOP is an XSLFO implementation, and with the main target of transforming XML documents to a PDF representation. Can be used very good for generating a PDF representation of anything you have, for example, for web pages, if you use XML also for generating these HTML pages. What's to mention is that with all those libraries and tools, nothing fits all purposes. You will end up choosing this library or that library for different purposes if you want to program anything. A few pointers to where to look. This is the website from Adobe where the specification and additional documents reside. Also a PostScript reference manual there and the font specification and things and everything else. This is the main page for the PDFX project. Planet PDF is a fine place to start where to search for forums. PDF Tools claims to be an independent collector of tools, but is very commercial. PDF Zone has a great portal for jumping to some other places about PDF and gathering information. And the Comptext PDF news group is also a very good place, and you usually get very quick answers. Usually the same folks are around in all those places. Okay, any questions?